हेलो एवरीवन, वेरी गुड इवनिंग एंड वेलकम बैक टू शिष्या क्लास यूट्यूब चैनल। तो आज हम पढ़ेंगे मैथमेटिकल इंडक्शन। इट्स अ पार्ट ऑफ आवर जेईई फाउंडेशन सीरीज। लेट मी टेल यू दिस मैथमेटिकल इंडक्शन इट्स हैज अ ह्यूज स्कोप। कहाँ यूज होता है, वेयर विल यू यूज इट? नाउ लेट मी टेल यू दिस इज an indirect method of finding what it helps us to prove complex mathematical formula, complex mathematical problems को हम solve कर सकते हैं मैथमेटिकल इंडक्शन के द्वारा। Let me introduce myself. I'm Pawan Yashwant. I'm a maths expert teacher at SISYA CLASS. I have 5+ years of experience. I'm a graduate in Bachelor's in Technology with an experience of 20,000 plus students. I'm from Geetham, Visakhapatnam. Now coming to what do you see? What is this picture? You call this what? Dominoes, right? Dominoes. Yeah. One second. Yeah. Dominoes. What does it do? When you're pushing, these are some bricks, you could say 1 2 3. You're doing such a thing that when you're touching one of it or pushing one of it, it falls on the other, and that falls on the next one, and the next one falls on the other, and so on. It continues until the last one is fallen. Right? This is a dominoes. Why am I teaching this? Now let me tell you, mathematical induction is something of this sort. What we do is we actually consider first element. Like in order to find a formula, in order to prove a formula, we'll be using this first element. We use this first element to what? It's like creating a chain of reaction, continuous chain of reaction, if you ask me. See, this is a continuous chain, right? One is falling to other and the other is falling to another. It's nothing but the continuous chain of reaction. It's like proving. The steps are extremely easy, and please listen to this. Let me take the first one as K. This first domino that you see is K. Now let me tell you, if you have millions and billions of dominoes, okay. Now if you push one, what is the chance that all of them will fall down? It's really less. You can't go and tap each one of it. So in what case can you know that all of them will certainly fall down? There are basically two cases. First, or you could say, two cases. First one is you should definitely push the first one. You should definitely push the second one, and you should make sure that it falls on the another and that one falls on the next one equally. Right? If this is falling, you should be sure. 1 2 3. This is what we'll be doing in this mathematical induction. So this is K. This is the first one. What would this be? If this is 1, let me take this is 1. What would this be? This is 1 plus 1, and so on. Now we'll be solving sums. Then you can easily understand this, right? Now this is the start point, and then the chain reaction will start. Right? Let's see the basic definition of this. It is an indirect method that helps us prove complex mathematical formulas that cannot be easily proved by direct methods. So this is an indirect method that is really helpful in solving complex mathematical formulae. What are complex mathematical formulae? Let us see. In arithmetics or in progressions we saw it. Sum of n terms. What is the n into n plus 1? How did we get this? How is it right? If you are asking me, we can definitely prove it by this mathematical induction. Okay, let's continue. So we have seen this, right? The first step, there are only two steps in this. The first one is called base case, and second one is called inductive hypothesis, and then you have to prove that hypothesis, inductive proof. Okay, the base case or the basic step. For this, we will consider P of n. P of n is true for n is equals to 1. What this means? Basically proportionality, you could say. Proportionality statement. This is of n is true for n is equals to 1. Most of the cases you will be taking n is equals to 1 only. Rare cases you might take n is equals to 0. Got it? Let's see the second step now. This is called inductive step. Now in this step, we will assume that it is true for n is equals to k. Then P of n is true for n is equals to k plus 1. We will assume n is equals to k, then we will see this. We'll prove this actually. Okay, we'll put the value of n as n plus 1, and then we'll check our equations. Now, this is the first sum. You saw this, right? 2, 4, 6, even numbers. So the last term is 2n, right? Even numbers. First 2 is 2 into 2, 4, 2 into 3, right? Even numbers. Now the sum of these numbers is given as n into n plus 1. Let us see this by mathematical induction. Now, how can we do this? The first step is P of, basically first is n is equals to 1. Let me write. Now, if I take 1, what will it come? For this one, this is 1, right? So, if I put this in 1, okay, let me write here LHS, I'll be getting 2. Now, if I put that in the right side, RHS, I'll be getting 1 into 1 plus 1. That is equals to 2. This is the first step. This is the first step. Now, what is the second step? So, RHS is equals to LHS. First term is equals to this value. Proved. Now, what is the second step that we will see? The second step that we will consider if P of k is true. Now, if P of k is true. Now, what will it come? If P of k is true, we'll be saying P of k plus 1 is also true. Now, how can we do this? If we put in P of in LHS, we would be getting 2 plus 4 plus, okay, 6 plus so on, plus 2 into k plus 1. We are putting n as k plus 1. So, this should be equal to k into, okay, k plus 1 into k plus 1 plus 1. Got it? We are just substituting this value. Now, what can we do? We can directly write this as k plus 1 into k plus 2. Got it? What were we doing? We were taking the first condition where we took, the base step where we have considered the P of n is true for n is equals to 1. We have considered the first term and we have got this. Now, what can we do? Plus 2 into k plus 1. So, in this case, we are continuing. So, in the first case, we have got LHS is equal to RHS. Then, P of k is true. If then P of k plus 1 is also true. With that we have proved this. K plus 1 is equals to 2 plus 4 plus so on, plus 2 into k plus 1 is equals to k plus 1 into k plus 1 plus 1. Hence, we have got that. If you check RHS, one second. This is equals to RHS is equals to LHS. Okay, you have got k plus 1, k plus 1. Now, in this condition, so in this condition actually first you have to add k plus 1, right? Okay, one second. Okay, so plus 2k plus 1, k plus 1 plus 2k plus 1. If you check this, the both LHS and RHS are k into k plus 1 is equals to k plus 1 plus k plus 1 into k plus 2. Let's continue. Right. Next is 1 plus 2 plus 3 plus so on, n is equals to n into n plus n+1 by 2. How can we do this? How can we solve this? Right. For this, we'll be considering the same. 1 minute. If n is equals to 1, first case, what is n is equals to 1? It is 1 on LHS. For RHS, what will be? 1 into 1 plus 1 by 2. That is 2 upon 2. This is 1. So, LHS is equals to RHS. Okay, you understood this. Now, what can we do? Now, coming to the second step or inductive method, where we are considering, assume P of kn is true for n is equals to k. Now, if we are doing this, if we are considering P of n is true for P of n is equals to k, then we will take P of, the second one is assume, okay, let me write this 1 plus 2 plus 3 plus so on plus k is equals to k into k plus 1 by 2. Okay. Now, the next step is adding k plus 1 on both sides. Let's add k plus 1 on both sides. So this will be 1 plus 2 plus 3 plus so on plus k plus 1. This should be k into k plus 1 by 2 plus k plus 1. Now, what can I do in the next step? If I check this, if I can solve this, this is k plus 1 plus k into k plus 1 plus, I can take k plus 1 as common. I can take k plus 1 as common. So I'll be getting, if I take k plus 1 as common, I'll be getting k plus 1 into k by 2 plus 1. K by 2 plus 1. I can write this as k plus 1 into k plus, let me erase this, k plus 2 by 2. I have just taken k plus 1 as common, then I have multiplied with this denominator so that it will be equal 2 into k plus 1, or yeah, I have just taken this inside so that I have gotten this equation. K plus 1 I have taken common and then I got this. I can write this as k into, okay, 1 minute, k plus 1 into k plus 1 plus 1 upon 2. K plus 1 plus 1 upon 2. So if you check this, this is 1. And if I check the LHS, what is my LHS? So that's equals to LHS. Got it? K into k plus 1. So basically this is the first term. This is k plus 1. If this is the first term, this is the second term. K plus 1 is the first term. K plus 1 plus 1. So please write darker. Okay, okay. So P of n is true for n is equals to k plus 1. Right. So by mathematical induction. By mathematical induction. Okay. So this will exist for every natural number n. It will exist for every natural number n. Okay. This is how we were doing. We were considering the first n case. Then we assume this is true for n is equals to k. Then we have put on the value n is equals to k plus 1. We added them both and the final we have got it as k plus 1 by 2. Okay, let's continue. Okay, I'm sorry. Right, let's continue. Next is 1 into 2 plus 2 into 3 plus 3 into 4 plus, okay, and so on. If you see what is in this form, what is the form? N into n plus 1, right? I can write, okay, this is, if this is n, this is n plus 1. If this is n, if this is n plus 1. So on into n plus 1. The sum of these terms is given as n into n plus 1 into n plus 2 by 3. Okay, okay. What is my first step? I'll check n is equals to 1. N is equals to 1. What if I do? LHS I have. First term I have 2. Now second RHS. I have 1 into 1 plus 1. That's equals to 2. Okay. Now I have this. So LHS is equals to RHS. Okay. Now what can I do here? The next step would be assume P of n is true for P of n is true for k. Is true for k. When we are assuming if this is true for k, the next step would be is n is equals to, okay, let me add this. Okay. I can write this 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on, k into k plus 1 is equals to k into k plus 1 into k plus 2 by 3. This is something I got. What is the next step? I would be adding k plus 1 and into k plus 2. I have both the terms, right? K plus 1 into k plus 2. I will be adding them on both the sides. I will be getting 2 into, just a second. 1 plus 2 into 3 plus 3 into 4 plus so on, plus k into k plus 1 plus k into k plus 2. So right hand side I will be getting k into k plus 1 into k plus 2 by 3, right? Okay, I will add this and then I'll be getting k plus 1 into k plus 2. Okay, now what can I take? I can take k plus 1 into k, right hand side I'll take k plus 1 into k plus 2 as common. If I take that as common in this equation, I'll be getting k by 3 plus, okay, I'll be getting what if I take both, k by 3 plus 1. 3 plus 1. If I open this in the, as I did in the last step, it will be k plus 1 into k plus 2 into k plus 3 upon 3. Okay, got it? What we were doing, we were just taking the adding the term x plus 1 into k plus 1 into k plus 2 on both the sides. In the end, we have got something. We have taken in this equation k plus 1 into k plus 2 as common. So we have got an equation like this. Now what we'll be doing? Right, next step would be, okay, I can write this as, in the last step I have written it as k plus 1. This is the first term. What can I write the second term? K plus 1 plus 1, k plus 1 plus 2 by 3. If you check this, this is first term, this is first term, this is first term. You are adding first term plus 1, second term plus 1, third term. Got it? Okay. Now, so by this what we can say? P of n is true for n is equals to k plus 1 by mathematical induction. Okay, let me just take you back to every step. First we have taken n is equals to 1, n is equals to 1, we have put the value, we have got the first term, then we have checked the right hand side, we have got 1 into 1 plus 1, 2, then we have assumed this is true for p is equals to n, n is true for k, then we substitute the value of n with k, while which we got this k into k plus 1 into k plus 2, then we added k plus 1 into k plus 2 both the sides, which we have received this k into k plus 1 plus k plus 1 into k plus 2. Finally we are receiving this only, right? Okay, got it? This is something we have received in the last by c, k into k plus 1 plus 1 into k plus 1 plus 2 by 3. This is something we are receiving in the end. Okay, let's go. Now this is the, okay, this is an AIEEE All India Entrance Examination 2005 question. If A is equals to 1011, I is equals to, okay, identity we have, unit matrix 1001, then which of the following holds for all n is greater than equals to 1 by the principle of mathematical induction? Now options are really important in this question. The first option is a power n is equals to 2 power n minus 1 into a plus n minus 1 into I. This is identity unit matrix. An is equals to na plus n minus 1 into I. N is equals to, a power n is equals to 2 power n minus 1 into a minus n minus 1 into I. A power n is equals to na minus n minus 1 into I. First step I'll take is, I'll take the value of a square. I'll take the value of a square. N is greater than 1, I'll take the value of a square. We have done this, right? Multiplying 1, 0, 1, 1. If I do it by row column, I'll be multiplying it, right? 1, 0, horizontal and the vertical column. I'll be getting 1 1s are 1 plus 0, 1 into 0 is 0, I'll be getting 1. Now in this second case, I'll be considering this 1 into 0 is 0, I'll be getting 0. Next is, I'll be getting 1 into 1 is 1 plus 1 into 1 is 1, 1 plus 1 is 2. Finally, I'll be getting 1 into 1 is 1 into 0 is 0, 1 into plus 1 into 1 is 1. This is what your a square is. And now, what let's do? Let us take a cube now. A cube is equals to a square into a. Now, what can I write this? How can I write this? If I take this value, I'm checking now, I'm checking for every term. I'm checking for every term. For the first time, this is the first time I have, right? For the second term, see, if you check the second term, this is the term changing to n is equals to 1, n is equals to 2. So this is the term that is changing. Now let me check for n is equals to 3. If this is true, then I can proceed further. A square I have 1 0 1 0 2 1. I have a as again 1 0 1 1. Now, okay, if I solve this, what would I be getting? 2 by 2, 1 matrix. 1 into 1 is 1 plus 0 into 1 is 0. I'll be getting again 1 here. If I multiply this with this column, 1 into 0 is 0, 0 into 1 is 0. I'll be again getting 0 here. Right, then I'll be taking this row. 2 into 1 is 1 plus 1 plus 1 is 1. That is 2 plus 1 is 3. Finally, 2 into 0 is 0 plus 1 into 1. See, you can see this, right? A1 I have 1 here. For A2 I have 2 here. A3 3. So this is continuing. So this is continuing. Next so this basically means that if I take a power n, then it's basically 1 n 0 1. This is for a power n. Any n number, any nth term you take, it will be in this form only, 1 n 0 1. If it's for 4, it will become 4. Remaining all the terms would be the same. So let me, what is it saying? Identity also I have, right? I'll minus it with, see on the options of this minusing with 1 identity, right? I can do that, n minus 1. N minus 1. If I do it n minus 1, it won't change, right? N minus 1 if I do, that should be, okay, 1 minus, okay, this is n minus 1, I'll be writing n minus 1, 0, n into it will become n. N minus 1 into 0, it will become 0. Finally, I have n minus 1. Okay, understood. This is basically into I. Right, 1 second. This is for n minus 1 into I. N minus 1 into I, this will be the matrix, because this will become n minus 1, n minus n will become 0. This is n minus 1, 0, 0, n minus 1. Now I'll take NA. If I take NA, that will be n, 0, n and n. Because that's right, one A matrix I have 1, 1, 1. So those will be replaced with n, n and n. Now how can I proceed? Let me consider this as 1 and this as 2. If I subtract both of them, 2 minus 1, I will be getting NA minus n minus 1 into I, okay, like this is 1, is equals to, if I subtract both of them, n minus 1, 0, 0, n minus 1, okay, and n 0, let me write minus 0, n and n. If I subtract both of them, I'll be getting n minus 1 minus n, I'll be getting 1, and next one I'll be getting 0, n minus 1 cross, subtracting directly the terms, subtract directly the terms. Okay, so in this I'll be getting 0 minus n, this is minus 1, minus 1, this is minus 1, n minus 1 minus 1, I'll be getting minus 1. This also I'll be getting n minus 1 minus 1, minus n, I'll be getting minus 1. I can also write this as minus, if I take, I'll be getting, okay, let me do it, I'll subtract it in reverse order. Let me subtract it in reverse order. 1 second. Okay. Okay, 1 second. If I subtract that, I'll be getting, okay, NA minus n minus 1 into I would be equal to, it will be positive this time, is equal to, okay, 1 second. Minus 1 and minus, yes, this would be equal to 1, 0, n and 1. If I subtract it, n minus 1, n minus n minus 1. See, this one I am subtracting it from this, n minus 1. This will be n minus n positive 1. So this will be cancelled, right? Let me write na minus n minus 1 I is equals to 1. If I take n minus 1, it will be positive 1. For this it will be 0 minus 0, it won't change. Second thing, this n minus 0, it will be n. And finally this will also be n minus 1, that is n minus plus 1. So that will become 1. If you say this, this is in the form of a power n. A power n, a power n. Right, this is in the form of a power n. So that's nothing but our form, a power n. A power n. Yes. So a power n is equals to na minus n minus 1 into I. This is what we have gotten. I is the identity 0, 0, 1, 0, 0, 1. Only the principal diagonal elements we have. So that's the process we did. Let me once again tell you. For this, we have given the first term, then we have found the second term by squaring it. This would be the second, where it become 2. For the third term, we also checked this. That's the change I'm getting here. 3 I'm getting here. Got it? So I have found out that an is in the form 1, 0, and 1. For n minus 1, I'll be getting n minus 1, 0, 0, and n minus 1. Into, this is identity into identity. And the final value of n into a, I have a as 1, 0, 1, 1. I'll be getting n 0, n. Now I'm subtracting both of them, na minus n minus 1 into I, by which I have received the value of a power n. I have received the value of a power n. This is the value of a power n. So a power n is nothing but na minus n minus 1 into I. You understood this class, guys? Okay, let's just take a look at it. So basically there are 2 steps in this mathematical induction. First is where you have considered the P of n is true for n is equals to 1. We have compared both the sides, LHS and RHS. You check the first term on this side, we have check this right hand side by putting n is equals to 1. So that's the first step. If it's true, then we'll proceed to the second step, which is the inductive step, where we have taken a hypothesis, and then we have, to prove it, we have taken k plus 1. Right? When it is true for n is equals to k, then P of n is also true for n is equals to k plus 1. Right? So this is how we have done these sums. Okay. Hope you guys enjoyed this session, guys. If you want more sessions like this and more topics, we are launching a elite batch for grades 8th, 9th, 10th, 11th and 12th. A course that is completely crafted by the IITians themselves. Now you will ask me, why should I start early, sir? I am in 8th class, I'm in 9th class. Why should I start early? Let me tell you guys, the exam that you are going to write is of huge competition. Around 13.5 lakh aspirants appear it every year. And out of the merely 2.5 lakh people, go to the next advanced level. And top thousands people go to the top IITs in the country. Now, so this will give a huge advantage with the competition, right? Your concepts will be stronger, you will be having more practice, and the rank or the seat deciding ranks all are conceptual based questions only. Means you have to derive a formula right away there, right? They'll give you the condition, right? They'll give you a condition. Now, what would happen if this conditions change? You have to derive a formula and then you have to tell them in the options. Now, this is really possible only if you have strong grasp on the foundation. Now, second is managing time, right? You'd be having so many works. Like if you're doing it only for 1 year or 2 years, right? You have to go to coaching, you have to manage your college syllabus, and there will be practicals, etc., etc. So this will give you a huge lap to manage your time, and it will also give you better critical thinking ability also by solving more concepts, more problems, developing more concepts. So you can definitely develop more critical thinking. And finally, it will also help you feel the real competition. When you prepare, you also give mock tests, right? Tests, pre-exams to check how much you know about a concept. So this will also make you feel the real competition beside you. Now, who will teach you in this foundation course? Since the course is crafted by the IITians themselves, it makes sense for them to teach us because they themselves have cleared this examination, right? So they know the process, they know the thought process, they know how should you go further and all. So they'll be leading you here. Next is syllabus. Sir, what syllabus are we going to cover? Let me tell you, we are going to cover syllabus based on 11th and 12th JEE, from basics to the advanced level. Obviously, you need to have your concepts clear, right? Without your basic concepts being clear, we can't go into in-depth concepts. Got it? Then we have, where is it happening, sir? Our classroom. We are having it live on our SISYA class app. We're having live on our SISYA class app. It's not going to live on YouTube. is going to live on our SISYA class app, where you will be accessible to live quizzes and live ranking system and continuous progress tracking. This is the most important thing in this page, because you might be weak in one concept. We will get to know how, like, if you are weak or not by the marks that you're getting, right? We'll ask you, is the concept clear? Do you have any more doubts, etc., etc. So that this progress tracking system is really important in your journey. And next, coming to our doubt resolution or support system, we will be giving you AI 24/7 doubt help system, where you will be able to upload a doubt in the type of messages, voice, chat, etc., etc. Then you will also be accessible to one-on-one mentor sessions. If you have doubts, if you have questions, if you have any concepts, classes, they are not cleared, you can access this one-on-one mentor session. If you have more doubts, if you want to connect directly to your master teacher, that is also possible, right? They will be available from morning to evening, where you can definitely ask them any doubts you have. And finally, we have this amazing feature of AI plus mentor collaboration, right? These are the things that we are providing. Now coming to self-study. Yes sir, my doubts are cleared. I don't have any doubts. I want to practice sums on this concept. We will be providing you with daily practice problems. You're gonna learn some, you're gonna learn some concept. This example is you learned induction. Okay, induction. Okay, let me say you learned it. Now you have to do some problems. We will be providing some problems on them also. Then you will be accessible with digital study material. Digital study material is accessible to you, and we'll be providing worksheets on the chapters we study. Then we have master level, where this is the last step before the final leap, right? We will be providing you with bi-weekly test and mock test and test series. Why is it useful? Why is it useful? So how can you know, how can we know, how can you know that how much you are so good at the concept that you have learned this week? So we will be conducting bi-weekly test and mock test and test series. Not only that is helpful for that, it will also make you familiar with the examination that you give. So that this is very helpful. Next is final prices. We have original prices as 8th, 9th and 10th for 39,999, 44,999 and 49,999. For multi-class packages 8th, 9th and 10th we have 89,999, 9th, 10th and for 65,999. Finally 10th, 11th and 12th we have for 2 lakh rupees. Since these are the people who realize it late, we do not have any seats left in this grades 10th, 11th and 12th. We only have till here Nana. And let me tell you, the seats for this are also nearly 81-82% full. We have somewhere around 18 to 19% of the seats left. Now, until this JEE Foundation series is live in YouTube, you will be exposed to a special discount, where you will be getting this 8th, 9th and 10th for 14,999, 15,999 and 16,999. Coming to multi-class package, we have 8th, 9th and 10th for 39,999, 9th and 10th for 30,999. Okay, let me not talk about this. Hope you enjoyed this session, guys, and please download our SISYA class app using this link, or you can easily available at App Store and Play Store. Right? If you like the session, please like it, share it, and subscribe it, guys. Thank you.